Hello everyone, this is Dr. Rajesh and I am again with you with my next video, and in this video we will study numerical problems on projectiles, and we will undertake a new numerical problem on projectiles, and that problem is also from important from examination point of view, and the problem is given by: a body is projected at an angle alpha to the horizon so as to clear two walls of equal height A at a distance 2a from each other. Show that the range is equal to 2a cot alpha by 2. So we have to prove that that is the range. So let me first form the figure. This is say x-axis, this is y-axis, and say this is the point of projection O, and a particle is projected from here to here. Say these 2 points, again read out the statement, at an angle alpha. So angle of projection is alpha. These are 2 points at the that particular trajectory which are of equal height. Say this point is A and this point is B, and height is equal to A. This height is A, this is also A, and this distance is given to be 2a. So this is 2a. Say this height is a, so this coordinate is a. Say this is x2 and say this is x1 comma a. So in this we see that this ordinate in both, because height is equal a, so is same, but axes are different, x1 and x2. So this is x1, this is x1, and this distance is x2. This much is x2 minus x1. So therefore I can say that x2 minus x1 is equal to 2a. This is the equation number 1. Fine. We know that equation of trajectory is given by y is equal to x tan alpha 1 by 2 g x square by u square cos square alpha. Now we notice that this point a comma axis are different laying upon the trajectory, so it will satisfy the equation. So corresponding to ordinate a, we suppose that abscissa is x and this is laying upon this trajectory. So let us see what happens. Let x comma a be the point laying upon the trajectory. So this implies that it will satisfy its equation. So I am going to write a, this is x tan alpha minus 1 by 2 g, this will be x square, this is u square cos square alpha. Okay, and we have to prove that range is equal to, we have to prove range is equal to 2a cot alpha by 2. So here we could also write range by formula is given by u square sine 2 alpha by g, and you may name it as equation number 2. Fine, this is quadratic in x square. So what we will do, we will make x square coefficient as 1. So for this we will cross multiply with 2u square cos square alpha by g and along with minus. So I am going to multiplying both sides with minus 2 u square cos square alpha by g, we get. So what will be getting? This implies that minus 2 u square cos square alpha by g, a, this will be tan alpha multiplied by minus 2 u square cos square alpha by g into x minus, and it will be plus x square. So this will be implies x square minus 2 u square by g. This will be tan alpha is sin alpha cos square alpha, and here is x, and this will be plus 2 u square cos square alpha into a by g is equal to 0. This cos alpha will cancel out, so this implies that x square minus, this is the formula for range r, x plus this will be 2 u square cos square alpha by g into a is equal to 0, because r is equal to u square from equation number 2 sin 2 alpha. So this will be 2 u square sin alpha cos alpha by g. So if we see here in this particular, that x1 and x2 are its two roots, x1 and x2 are its two roots, because these values are corresponding to same ordinate a, we have put in the here as ordinate is same, so we are getting two values, and in the problem one value is x1, another is x2, so obviously x1 and x2 will be its two roots. So I am going to write that let x1 x2 be its two roots. This implies that sum of roots, we know that x1 plus x2 is equal to minus b by a, so this will be r by 1 and minus, here is minus, so this will be r, and product of roots is given by c by a is equal to 2 u square cos square alpha divided by g dot a, and you may name it as equation number 3 and equation number 4. We know that this is equal to this one. We know that x2 minus x1 is equal to 2a. This is given from equation number 1 also. x2 minus x1 whole square is equal to 4a square. This implies that this can be written as x2 plus x1 whole square minus 4 x1 x2 is equal to 4a square. Okay. Now from equation number 3, x1 plus x2 is r square minus 4. From equation number 4, I am going to put the value 2 u square cos square alpha dot a by g. So this is further equal to 4a square, and from the formula for range, u square sin 2 alpha by g is equal to r. So this implies that u square by g is equal to r by sin 2 alpha. So I am going to use this value r square minus, it will be a 8a, this will be cos square alpha, and u square by g will be substituted r sin 2 alpha is equal to 4a square. This implies that r square minus 8a cos square alpha R sine 2 alpha is 2 sine alpha cos alpha is equal to 4 a square. This cos alpha will cancel out, this 4 will cancel out. This implies that r square minus 4a, it will be cot alpha r is equal to 4a square. This further implies that r square minus 4a cot alpha r minus 4a square is equal to 0. Now which is quadratic in R and can be solved as 4a cot alpha plus minus 16 a square cot square alpha. This is plus 16 a square, and here is the square root divided by 2. This is implies that 4a cot alpha plus minus 4a cot square alpha plus 1. Here is the square root divided by 2. This is r is equal to 2a cot alpha plus minus 2a. This is cosecant alpha. This implies 2a cot alpha plus minus cosecant alpha. So r can be plus or minus. So we will see both the terms for plus as well as minus. Firstly, we are going to take the minus 2a cot alpha minus cosecant alpha. So this will be 2a cos alpha by sin alpha minus 1 by sin alpha. This will be minus 2a 1 minus cos alpha divided by sin alpha. This is equal to minus 2a. This formula is for 2 sin square alpha by 2 divided by 2 sin alpha by 2 cos alpha by 2. This will cancel out, this 2 will cancel out. So we are left with minus 2a tan alpha by 2. But alpha is less than pi by 2. This implies that tan alpha by 2 is greater than 0, implies r is less than 0, which is not possible, which is not possible, hence rejected, hence rejected, hence rejected. So this portion we have rejected. Next we are going to take the plus sign. 2a cot alpha plus cosecant alpha is equal to 2a. This will be cos alpha by sin alpha plus 1 by sin alpha is equal to 2a 1 plus cos alpha divided by sin alpha is equal to 2a. This will be 2 cos square alpha by 2 sin alpha by 2 cos alpha by 2. This will cancel out, this will cancel out. So we are left with 2a. This will be cot alpha by 2. So range is equal to 2a cot alpha by 2. Since you can see alpha is less than pi by 2, implies cot alpha by 2 is greater than 0, hence r is positive. So this is the what we require to prove, and this question is very important from the examination point of view. So this is all I have from this lecture, and in the next video lecture we will taking some other problem of projectiles. So this is time to say goodbye. This is Dr. Rajesh saying you goodbye, take care, bye bye.